This video is possible thanks to contributions to the Existence University Patreon by viewers like you. Thank you.
Hi, my name is Ryan, and I have a few things I would like to address, especially to the objectivist community. We have some things to talk about in regards to mathematics, especially dealing with the triple integration. It has come to my attention that many objectivists, following on the heels of others who have no mathematical experience, have essentially decided that math is not real, that math is not for us, that we don't need math. At most, we need to be able to count to 10, maybe 20, and that's it. There are many issues to address here, and I would like to get started by addressing a few concerns. I have a lot of concerns. Before we get started, here are some things that I would like you to know. 1. I'm trying to be nice, but I'm a bit autistic and have an openness score of 98, but an agreeableness score of 10. So I will listen to everything you have to say, probably a few times. But I will tell you at the end that I think you are stupid. This is because 3, I am a genius and think everything is stupid. I don't mean it, and I could choose other words to describe stuff that I disagree with, but they would probably also hurt your feelings. So, what I mean when I say I think something is stupid, I tend to mean do better. 4. My goal is the betterment of all human lives and the prosperity of the quote-unquote objectivist movement. 5. I love and respect the works of Harry Binswanger. But due to item number 4, I have to step in and fix his errors. And due to items 1 through 3, I will probably upset the sycophants. Here are some further things to consider. 1. I am an objectivist that discovered objectivism by formulating it on my own, and then, after, discovering that Ayn Rand had beat me to it. 2. As such, I put myself before any tribalism. 3. I have listened and read all of Peikoff's and Binswanger's work, and was able to correct them on the spot first time listening to them, only to discover that decades later they would come to correct themselves in the manner in which I was going to correct them. 4. I don't care if this offends you. I believe it is true, and I am willing to be tested on it. If only someone had the balls to face me. 5. Everyone runs away from me. I am beginning to feel like a bit of a boogeyman. But, that being said, I have nothing to lose and everything to gain. I'm here to correct Harry Binswanger, despite the fact that he holds such a high prominent position among objectivists. Something needs to be done in order to restore mathematics to its proper place in reality. First, let us begin by showing all of the places in this most recent Harry Binswanger lecture where he himself, not Ayn Rand or quoting someone else, where he himself was correct. Let us see a montage of those clips.
So it's a tool. It is not a communion with a perfect mathematical object in another dimension that we can only see with our mind's eye, not with our real eye. It's a tool for calculating measurements.
Okay, now, here is a montage of all of the places where I would have to step in and correct him.
Ancient Greeks discovered there is no number that when multiplied by itself gives exactly 2. Rumor has it that they took the person who discovered that and threw him off a cliff. But it is a science of measurement. It's a science of measurement calculation. It's a science of inferring some measurements from others.
So, part 1. The Emperor has no clothes. I would say, in my opinion, that the objectivist movement is well known for its no true Scotsman fallacy issues. If you have ever met an objectivist, especially as an objectivist, you have probably been told by that objectivist that you are not an objectivist, because of one or two things you disagreed with. Not things that Ayn Rand wrote, but just things that they personally disagree with. It is an all too common feature of this group. And as such, it is my belief that no one has the balls to tell Harry Binswanger that he is dead fucking wrong. As an example, every single time someone asked him a question that he did not give an answer to, or did not know what they were even saying, no one stepped in to correct him. No one stepped in to say, that's not what I mean, or that doesn't make sense. Even when they were pointing out contradictions, and then he would not answer where the contradiction was and say something entirely irrelevant, they would just thank him and move on. Given that the objectivist movement is so quick to throw out members that disagree in any fashion, it is no wonder that no one in the audience has the balls to tell Harry, one of the last remaining working members of the closer inner circle or outer circle of Ayn Rand's collective, that if anyone were to ever say anything against him, they're out. Well, that's okay with me, for, as I had stated, I formulated objectivism on my own. I am happy to have Ryan Cooney's objectivism as opposed to Ayn Rand's objectivism. Mine would be identical to hers, except that, no, it's identical. The only people who disagree are A or I. Those who currently hold the opinion that they are objectivists and would try to kick me out would do so because I agree with Ayn Rand and not Harry Binswanger or the members of ARI who believe that you can be whatever gender you want. That essentially covers a quick brief summary of part 1. The sycophantic nature of objectivists have seemingly caused Harry Binswanger to construct a mathematical idea which holds no ground, has no foundation, is poorly researched, entirely based on his feelings, but if you say anything, I'm sure you will get kicked out of objectivism. So, no one has said anything. So, he thinks that he's got something really good here, and he doesn't. The Emperor has no clothes. Part 2. Let's deal with the actual philosophy of mathematics. I can do a full reaction live stream, or just video on the computer. Here today, let's go through some of the philosophy of mathematics that entirely went over his head. In the first case, what is the exact identity of the hypotenuse? Question: what do you mean by exact? And I'm quite serious. Are we talking in terms of quantum exactness? Are we talking about precision, micro machine precisions of exactness? Are we talking about rough approximation exactness? This is very important conceptually given that mathematics is in fact a form of concept formation. This is where Harry Binswanger is seemingly entirely disagreeing with Ayn Rand. Mathematics and concept formation are tied together. They're one and the same. They're different ways of looking at the same operations. One gives you more of a quality. One gives you more of a quantity. But a quantity in one sense of the universe from a perceptual point of being is actually a form of quality. The quality of a oneness in a quantity of that thing almost go together, but there's something not quite there. Something like neurology that would help us tie these things together, which is my work, the triple integration, or my continuation of Ayn Rand's work in the triple integration, to better put it. That's why I disagree with this rejection of mathematics. What is the exact identity of the hypotenuse, you ask? Why, it is the side of an actual square. For the issue that he has presented has given us the triangle of squares. What do I mean by that? Well, Pythagoras' theorem, what is it? A squared. What does that mean? It means a square. It means an actual square. A. And you put that up against, from one corner, a square of B. If you start at this point and you moved 1 unit this way and 1 unit down, your fingers are now a distance apart. And if you were to bring them together, the line that exists, where no line is, but in your imagination, would be the side of a new square. The square, if you were to take the parts of the other squares, chop them up, and reformulate them into a new mapping, a new square, that square area is 2. It has to be, right? Because one of the areas is 1, plus adding all of the squares of the second area. That's 2 1-unit areas. That gives us a new square of 2 units. If it is a square of 2 units, constructed from blocks which are giving us literally a 2-unit block, what is the length of the side? Well, it's a square, which means that the length and the width are the same. And so it is the square root of 2. That is the exact identity of the hypotenuse. It is the side length of a square that physically exists when we move the blocks from one unit to the block of the other. This is why I mean, what do you mean by exact? Harry has seemingly gone all the way down to the quantum level. And given that nothing can be so precise as to actually go on forever, he has rejected the ability to have the square root of 2. For that is a number for every time you zoom up. You always end up between the notches. And as such, you cannot zoom forever, and as such that number must actually cease. Now, here's a real conundrum for you. If 2 is a number, but the square root of 2 is not a number, I want you to consider what that means. It means when you zoom up on something that is a, say, length of 2, when you get to the end of it on the ruler, you are between or on top of the measuring notches, right? He gives an example of this when he does continuous work, and he brings it up to 5, and then 6 is over here, and there's just a little extra. So it's 5 point something. Well, when you zoom up on that, if you zoom up on that and it's still between the 2 notches, and then you zoom up again and it's still between the 2 notches, and then you zoom up again and it's still between the 2 notches, and then you zoom up again and it's still between the two notches, well, that number, you would just keep going, essentially, right? The idea being you go until it stops on a notch, maybe right exactly on one. But this is the real conundrum here. Because what if you zoom up on that? Is it between the notches or is it on the notch still? Say it's still on the notch. Zoom up again. Is it still on the notch? Yeah. Zoom up again. It's still on the notch. Zoom up again. It's still on the notch. Zoom up again. It's still on the notch. 2 is actually, in that case, when you continuously zoom forever, 2 is the length that always stops on that second notch. And no matter how much you zoom, it's exactly on that notch. The square root of 2 is such that you get to 1.4, 1, and then you just keep it, the size doesn't consistently stay the same. It moves around, but always between the two notches. Sometimes on a notch, sometimes it is on a notch, but then you zoom up again and it's between notches. In the case where you have something like 2/3 of something, if you take this as a whole unit and you say, let's cut it into 3s, say like here, when you zoom up on that first notch, it's going to be, say, from here, how was I holding this? From here to here, say that's 0.3. You zoom again, it's 0.3. Zoom up again, 0.3. Zoom up again, 0.3. That's all that means, right? So, the issue being, if the square root of 2 is not a real number, then neither is 2, because they exist by the same principle. That principle being, if you could zoom up forever, where does the line stop? Between the notches or on the notch? Is it continuously the same number when it's between the notches or on the notch? Or is it continuously fluctuating between the notches? Another example being pi. 3.1415 something something something, no one cares, but people who pretend that science is cool. If you actually liked science, pi is 3. Just FYI. Given that pi has this continuous number of like 1, 4, 1, 5, 9, 2, 6, 5, 6, 5, 3, 2, I'm making up numbers. It's saying that when you zoom up on pi, when you zoom up on a circle that's come to a complete end, as you zoom up, it's just moving the notch between 0 and 1, 0 and 1. Sometimes it's on one of those notches, but when you zoom up again, it's moved. That's the whole idea. So, the idea then being, if one of those can't exist, if pi can't exist, or the square root of 2 can't exist, or e can't exist, then neither can 2, or 1, or 0. Because you're saying it's a thing that does the exact same thing as the square root of 2, except in a more special case. And this is one of the big issues. Real numbers are called such, in fact, because they are more likely to be real than whole integer numbers. So Harry prefers the integer numbers because they're his counting numbers. 1, 2, 3, 4, 5. However, the big issue with that is this finger is different than this finger. They're different sizes. One of them is not actually 1, if that's how you want to think about it in different terms. If you're just counting objects, then that's fine. But what if we're not counting objects? Not everything is counting physical, concrete blocks of items. Some things are, like, say, he makes a joke that time is finite. Well, how is it finite? It's finite because it's going between the seconds. And it stops at a certain point, and it started at that the universe will eventually one day no longer have... Well, that's not true, though, is it? Because the universe can't end.
So there is a point at which things will stop moving relative to each other. But that's actually not true, because photons will always be moving relative to each other. They will just... You know what? It's not about this. So the issue is that what is the issue? If the square root of 2 is not a number, then 2 is not a number, because 2 is more special than the square root of 2. The square root of 2 is that which Harry is actually more approaching, which is this idea that if you were to have something that was 2 centimeters long or 2 inches long, when you zoom up, that it continues to be 2 forever, meaning it never deviates from that notch. And his whole point is that we can't really be that precise. Well, if we can't be that precise, then it won't always be exactly 2. The more we zoom up, eventually we will find that it's 2.00001. Well, in such a case, if something is 0.00001 or 2.0001, then the issue is 2's not real by that standard, right? So this is one of those issues between the difference between real numbers and integer numbers. An integer number is more abstract. That's the funny thing about this. The integer numbers are more abstract. It's exactly, in a sense, like the rest of objectivism. The axiomatic concepts are the primary. But they're the last thing you would ever think of, starting a philosophy from scratch in a world without language, developing the language, developing the philosophy. The last thing you reach is existence exists, A is A, consciousness is conscious. But in order to ever reach those, you needed to know that existence existed. You needed to know that things had identity, and you needed to know it. Did you ever say those things when you were born? No. And this is one of the things, really, honestly, that gets me with this video. When Harry says something along the lines of, like, if someone knows the number, like a quadrillion or some big number he makes up, that an infant didn't know that number when they were born. So therefore, it's not a real number because you have to learn it.
If you've got a 6-year-old, he may know the numbers up to 100, maybe even up to 1,000, but I bet he doesn't know what an octillion is. And if he didn't when he was 1.
Well, then nothing is real. Apples aren't real. Parents aren't real. Trees aren't real. Because when you were born, you did not have that word in your head. You didn't know anything about it. So that is a dead argument right there. Alright, we have not even fully stepped into this video. 2 minutes into this video, he gets a very wrong history lesson. Very wrong. It's very well known. It's not known if the story is real, but the story itself is very well known and very much told over and over and over. And so the fact that Harry got zero pushback on this really tells me that there is a sycophantic nature developing, a very tribal nature growing in objectivism. And that is that the Greeks discovered that there is no number that square root, that timesing itself gets you 2. That is fundamentally false. Now, first and foremost, it's false because it was discovered earlier than that. The Babylonians had this information. But we, in the Western world, tend to give credit to the Greeks. They did put things down more as terms of rational thinking and philosophy as opposed to the gods, and that's why we tend to do that. But Hippasus, I don't speak Greek, But that is the given name of the man who was a member, now, note this, he's a member of Pythagoras' cult. So, when Harry says the Greeks discovered, first and foremost, there is a big difference, in one sense, between the Greeks and Pythagoras' cult. Pythagoras is a Greek, for sure. But his cult, the cult of Pythagoreanism, versus Platonic schools, or Aristotle schools, or Epicurus, are entirely different. Pythagoras thought the universe was made of mathematics, and this is one of the things I find very funny. I think Harry is, in fact, in one sense, a mix between Pythagoras and Plato. For the sense that Pythagoras seems to say that the square root of 2 cannot exist. And that's why they had the man drowned in the sea. So the fact that you got that story wrong, and the fact that you associated it with the entirety of the Greeks as opposed to a mathematical cult that rejected the square root of 2, nearly for the same reasons you do, is a very telling issue. No research was done, and no one called it out. Next issue, 5 minutes in. The science of measurement calculation. Wrong. Just wrong. It comes in too late. This is one issue that Harry Binswanger has been prone to. He has done this with thinking itself, where at one point in his reasoning, he had some sort of conclusion that you kind of needed to conclude what you were going to focus on in order to get focusing, in order to get focus, in order to get focus. And he threw that away and has fixed that sense. But now he has returned to it in the form of mathematics. The science of measurement calculation. The calculation is a measurement, and it is itself a science. And a measurement is a calculation, and a calculation is a measurement. And you have to have one before the other. And that being, you have to be able to measure differences perceptually before you can calculate differences conceptually. Calculation is a conceptual thing, and mathematics is, in fact, an epistemological thing. What does it mean to have quantities as metaphysical, but the numbers as epistemological? Metaphysics is that which is. Our experience of it, which includes such things as quantities, comes from our sense perception. I cannot tell you the difference between two objects without seeing them, or feeling them, or smelling them, so on. So, when one says that quantities are metaphysical, that is quite a revealing statement. For what does that actually mean? For all we know, everything is actually one, and the way in which we see the world is to distinguish them, to rip them apart in one sense or another, and to see them as different objects. Or that they are, in fact, entirely different objects. Now, one of the big issues is, what is the universe made of? By the objectivist standards, we kind of have to follow a type of Parmenides thought experiment. That which exists is, that which is not, that which is that which we identify, and that which is not cannot be seen or thought of. And as such, the universe is made of a continuous amount of stuff, a oneness. The little stuff that exists where nothing isn't. And as such, we have to think about this quantity as metaphysical. If the universe is a bunch of little stuff, what's between the little stuff? Presumably nothing. But what is the quantity then? That is a big issue that we need to discuss. Let's move on, though. About 13 minutes in, talking about Russell. A number of a class is the class of all those classes that are similar to it. This is correct.
That is what it means to have a certain amount of numbers. When I have here 2 pencils. I know that this is 2 because the number 2 of the class of 2-ness is similar to when I have, say, these 2 Rubik's Cubes. There are 1, 2. And that is similar, and this is very objectivist speaking. Similar is an objectivist concept. This is similar to this. And in fact is different from this. Because this is 1, 2, 3, and that is dissimilar from 1, 2. But I can now, let's just say, since this is not a pencil, and these are pencils, and these are Rubik's Cubes, and this is not a Rubik's Cube, well, maybe there is 1, 2, 3. And there is a similarity. And all of this is very epistemological. I get to decide if there's 2 here, and if there's 2 here, or if there's 3 here, and 3 here. It depends on the unit I select. Are there 3 objects here, or 2 Rubik's Cubes? 3 objects, or 2 pencils, or 1 pen in 1 container? What do you see? What you see and what you describe, in one sense, is entirely up to you. And the way in which we know that this is 3 things, but 2 pencils, but 1 pen, is that the number of a class is the class of all those classes that are similar to it. Moving on, infinity. Infinity being rejected because it is an old word is pure rationalism. The concept of infinity is not meant to be a metaphysical, real, concrete object. It is just an idea. And objectivism should have no problem with conceptual, abstract ideas. The idea being that if you were to allow something to continue forever, would it be good to allow it to do so? Would it get you a result or not? For example, if you were to ask the computer to forever look for a number which is greater than 2 but less than 1, the computer will continue the operation forever. It will not actually go forever, and everyone knows that. Of course the computer will die. Of course the world will die. The sun will die. The universe will die. And it'll all come to a crashing halt, and there will no longer be this issue. But if we were to imagine it, what would happen? And what would happen is if that computer were to continue existing long after the death of the universe, it would continue looking for that number forever because it does not exist. But if you ask the computer to forever look for the next prime number, one day it'll pop out a number. It'll stop. And the fact that it didn't actually go forever is not an issue for mathematicians. We don't actually want things to go forever. We want to know, if I were to attempt such a thing, what would be the result? One such example is a bell curve of probability. A bell curve comes in like this, and it goes up, and it comes back down, and it goes out, and it kind of goes out forever. But it gets smaller and smaller and smaller as it reaches the 0 line on the axis. Now, the question is, if I were to chop it up into an infinite amount of rectangles, does it add up to a number? Yes, it does. It adds up to 100%. So if you were to look for some limit on some probability of bell curve, as x approaches infinity, so it's going to go that way forever, what will be the result? The result will be that you will eventually have 100% of the population censused or measured or whatever. And therefore, it's a good operation. If we allow this to go forever, we get some result. Cool. And that's exactly like the square root of 2 versus the 2 issue. If we were to continuously measure 2, something that is 2 units long, forever, will it always be 2? And if the answer is yes, cool, it's 2. And if it's not, then it's not. Is it definable by a rational number or not? If it is, cool. And if it's not, cool. Next part. Misreading Cantor's Wikipedia page.
And Wikipedia says about him the following. Cantor established the importance of one-to-one correspondence between the members of 2 sets. Yeah, I think that's called counting. He defined infinite and well-ordered sets.
The Wikipedia page reads, if you do not insert words, like the word define, it reads that he found a one-to-one correspondence between infinite sets and well-ordered sets. Not that he found one-to-one correspondence and defined infinite sets and defined well-ordered sets. No. Harry. That is purely cherry-picking and misreading. There is nothing here. Absolutely nothing here. In fact, Harry proves it. He shows that an infinite set can be equal to another infinite set of the same order. For example, all even numbers can be matched to regular numbers, but they cannot be matched to real numbers. Let me explain. If you have 2, you can assign that the value 1. So, every time, say, a party guest comes to your home, you have a bunch of gifts, and each bag has 2 more items in it than the last bag. One person comes in and they get bag with number 2, 2 items in it. Next person comes in, they get 4. Next person comes in, they get 6. Next person comes in, 8, 10, 12, 14, 16, 18, 20. You understand. So, if you were to continue this process forever, for all humans that will ever be born and will come to your house, and let's just imagine it's an infinite amount, what will be the result? And this is the issue. We don't care that you can't go for infinity. The question is, if you could, what's the result? And the result is that you would have to continuously add 2 more items to each bag for each person, forever. And they match 1-to-1 every single time. 1-to-1 correspondence between 2 infinite sets. You cannot do this with real numbers. For if you put in the first object, or the first bag, you put in 1 object, and for the second person's bag, you put in 1.1 objects, then you could put in 1.12 and so on, but you could also have put in 1.105, or between those two, 1.05. So there are other numbers that you can insert in that sense with the real numbers. So you can have an infinite amount of numbers that fits inside of that first set. Some infinities are larger than others. There's nothing wrong with that. Especially when you don't actually hold infinity to be real, but an idea. And something that, when pairing off 1-to-1, will get you different results. Later, 32 minutes in, he entirely seemingly misunderstands discrete versus continuous by giving us a what appears to be a continuous line, but is cut up into discrete parts. If it's not continuous, that is discrete. So, I don't even really, in a sense, know what to say to that. Next up, math to serve its masters. This is not the purpose of mathematics. Math is not to serve physics, engineering, and finance. Those are not its masters. If anything, it's the other way around. However, I can argue that, but I think it's more funny to argue alongside Harry and say, yeah, let's let math serve its masters. In which case, we have an issue with Harry's work, not with math. For one of the things Harry says in this video is that, I believe, let's see, in the question period, do I have it in here? Yeah. Negatives, reals, and complex. This was during the question period. If math is to serve its masters, and Harry says negatives don't exist in real life, well, we have a big issue. Physics tells us something about the nature of reality. And whether you want to call it positive or negative, let's, for now, call it credit and debt. There are things in this universe that take up a space in the universe and have mass. And there's another type of the opposite caliber, such that they almost weigh the same. They're different sizes and such, but one of the main things is they're complete opposite in what is called charge. Now, one of these things is like it has credit of charge, and one of them is like it has debt of charge. And when you put them together, it becomes zero. They become neutral. The thing no longer has charge. It loses a property. Like when oneness comes with negative oneness, it becomes nothing. And by Harry's argument, nothing is not really conceptually a thing. It's not a thing that it lost its property of quantity. Zero is losing the quantity, is losing a property of quantityness. Electrons have a negative charge, which you can say is a credit or a debt, and it depends on how you want to think about it. It can be either. We can also say the electron is positive. It doesn't matter. The issue is that the opposite exists. If one of them is to be said to be positive, the other has to be negative. They come together and they cancel each other out. The property disappears when they cancel each other out. Rip them apart and they have property. A new property emerged. One which is negative of the opposite of the other. They're, in that sense, opposites. Negatives are, in a sense, real things. Further, that electron can occupy the same space as another electron if, and only if, its complex value, a number, a two-dimensional number, is opposite. If they have the same, if they're both up, then they can't occupy the same space. You flip one, and they can. A property emerges from this real-life thing, which we can assign a complex number, a negative imaginary number. In fact, so the square root of -1 is actually a way of thinking about rotation. And rotations exist in real life. So, there is no issue with negatives, complex, or in the imaginary parts of complex numbers, or negative numbers, or, in that fact, real numbers. As we have already discussed, real numbers are, in a sense, more real than integers. Because when you have two apples, well, one of those apples has more apple than the other. It grew a little bit larger. So if you were to say one of them is really, truly, exactly apple, then the other one is more likely to be 1.3 apple. And in fact, if you really zoom up on the molecules because they're growing and decaying all the time, then you have actually a changing value, which is way more real than a continuous number that never changes and is exactly on 0 on the notch every single time. So, if math is to serve its masters, unfortunately, everything that has been rejected by that principle has to be reinstated, because physics has stated that the negative numbers are real, the complex numbers are real. Finance states that compound interest is real, which is E. That is another irrational number. So, I think it's much funnier to argue with Harry that math should serve its masters, physics, finance, and engineering, which is a wrong argument, but I will make it anyways, because by doing so, we have contradicted ourselves. We have proven, in fact, that negatives exist in real life, complex numbers exist in real life, real numbers exist in real life, that irrational numbers exist in real life. It's just, what do you mean in that sense of real life? My big issue is, it seems to me that Harry is being very Platonic. He seems to be seemingly wanting to reject Plato, but his argument is, since these things don't match the real forms, since there is a form of 2, and that's more real than the square root of 2, there is no square root of 2 form, and therefore there is no square root of 2, but there is a form of 2. So this will conclude the first part of my review of Harry Binswanger's work in mathematics. Upcoming videos will just cover the philosophy in a more in-depth way, in a less review-y way. And other videos will be out that will be pure reaction videos, where we might just do a live stream, or I just might record it, depending on how I feel. Or depending on how you comment. So, tell me if you want a live reaction, or if you don't. That's up to you, I guess. So, in the meantime, help me save objectivism from people who have very poor educations in mathematics. No offense, but they openly admit that. I happily admit that I have a minor in mathematics. I love mathematics. It is conceptual, it is epistemological, it is psycho-epistemological, it has things to do with your neurology, and things to do with your concept formation. It is a part of the triple integration, and that will be further explored, essentially, for the rest of my life. So, like, subscribe, share, and let's upset some ARI fans. Have a good night. This video is possible thanks to contributions to the Existence University Patreon by viewers like you. Thank you.